Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. Today we will start into a new topic, which is the relative motion analysis. Relative motion analysis using rotating axis. Okay, and let's call this. So this has some relationship to the topic that we have discussed before, which is relative motion analysis using translating axis. But this time we will have a rotating axis. So let us assume that we have a set of coordinate system or axis. Axis X is in the horizontal and axis Y is in the vertical, and at the same time this axis is rotating with angular velocity of omega dot, and also accelerating at the same time it is accelerating at angular acceleration omega double dot. And let's say that the object or the rigid body is here, and let's call this rigid body is A, and it also is the origin of the rotating coordinate system. And let's say we have another global coordinate system which is fixed and not rotating, and this is capital X and this is capital Y. And at the same time we have a particle B here, and it is moving. So we can now map out the relative position, and let's call this position vector B relative to A. And this is position vector A. And of course the long arrow is the position vector B. Okay, so we can represent the position vector B relative to A in the form of the local coordinate system which is rotating. So we can give xi plus yj. That is the coordinate system of the rotating axis here. So the xy is rotating, and we can measure or write down the position vector B relative to the rotating axis as position vector B relative to A, xi plus yj. I and j is in terms of the coordinate system, rotating coordinate system. And at the same time, we can now ready to write the position vector equation, with position vector B is equals to position vector A here plus position vector B relative to A. And if we differentiate the position vector, we will get d over dt position vector B equals to d over dt of position vector A plus position vector B relative to A. I can now replace this is directly because position vector B is fixed to the global, so we can say that this is VB plus position vector A is also fixed, so this is VA, and then we need to just concentrate ourselves, and we will replace this with the representation of xi plus yj. So we can now differentiate this in term. So we will have x double dot I plus x di over dt. Remember, I is not fixed, ij are rotating axis. plus y dot j plus y dj over dt. Now, if it is a translating axis, we don't have anything to do. There's nothing much. There's no change of direction and so on. But here we have a rotating axis. So what we must do now is we need to, when we do this operation di over dt and dj over dt, something else come out, and you can refer this to many books. I'll just write down what happened to when we differentiate the unit vector I over t. It becomes omega cross I. And similarly, if you differentiate unit vector j relative to t, dj over dt, it becomes omega cross j. Okay, so this is key to the understanding, and I'll just put a box here so that you can refer this, and we'll keep this. So if you refer this di over dt, di dt and dg over dt, we can rewrite this equation back to x dot I plus y dot j plus, in terms we have y dot j, which is dj over dt, let me clear. So x di over dt, we can write it down x omega cross I, and dg over dt plus y omega cross j. And we can rewrite this again as omega cross xi plus yj. And we can now simplify it to omega cross position vector b relative to a. So we can now rewrite the velocity term as xb. So we can bring down, so the velocity is vb equals to va plus vx dot plus yj, and this one we can simplify this to vb relative to a, yeah. And then we will have, this is omega vb relative to a, sorry. We have va here, sorry, we have va omega cross position vector b relative to a plus vb relative to a. So there are three terms here. That brings us the velocity equation for the rotating axis. So then we can proceed to the next item, which is what happened when we differentiate this against time. So d over dt, this term vb equals to, we now differentiate the whole term expression, omega cross position vector b relative to a plus vb relative. So I'm gonna put that x dot plus, because it's easier for me to do the differentiation later on. Yeah. So this one is straightforward. D over dt vb will have ab, and then d over dt va, we will have aa, and then we have to differentiate these two terms, d over dt omega cross position vector b relative to a plus d over dt x dot I plus y dot j. Yeah. So because this is when we open up this expression, it will become long, because we have to, by using the chain rule, we need to differentiate them in turn. So we will now do that separately. So let's look at the expression d over dt. I'm taking this expression here, and I'm going to do the differentiation here. So we take the whole expression, and we will have d omega dt is omega. This is omega dot, yeah. Sorry, omega dot. Yeah, I'm sorry guys. No, this is omega, yeah, omega dot. Omega dot. We have something wrong with the expression. But anyway, sorry, this is not omega dot. This omega is the velocity, the angular velocity. Okay, so d over dt omega, we will have omega double dot is omega dot, which is alpha. That is the and then we have cross position vector b relative to a, and then we have to do that in term. Then we have omega cross position vector d over dt, position vector b relative to a. We have done this before, d over dt xi. We have done this before, d over dt xi plus yj, and what we have is we have two terms. We have omega cross I, and we got, so this one, when we carry out this thing, the differentiation d over dt, we will have omega dot cross position vector b relative to a plus omega cross. We have, this is v relative, yeah, v relative plus, we have two terms. One, we have omega dot, omega cross d over dt, our position vector b relative to a, omega cross, then VA, we have VB relative to A, and then we've got VB relative to A plus omega cross position B relative to A. And finally, we will have this term as omega dot cross position vector B relative to A plus omega cross VB relative to A plus omega cross position B relative to A. Yeah. So while I am at this, let's go back to the definition. There might be something wrong. So here is that the angular velocity is omega. There is no dot here, and the acceleration is omega dot, which is equals to alpha. Yeah. So let's make that clear. So this is a rotating axis with omega, and omega dot is the angular acceleration of the rotating axis. So when we are here now, just finish completing the first part of the differentiation d over dt of omega cross position vector b relative to a. Now we need to complete this part, d over dt xi plus yj. So we are now going to continue with the differentiation of d over dt x dot I plus y dot j. We have four terms here, yeah? xi, yj, so we have to do using chain rule, we have to do them in sequence here. So d over dt x dot I, we will have x double dot I plus x dot di over dt plus d over dt y dot, we have y double dot j plus Then we have y dot dj over dt. Yeah. So this one we know that di over dt is omega cross I, and dj over dt is equals to omega cross j. Then we can now put that back here, x double dot I. Yeah, I'm going to regroup them again. Y double dot j plus x dot omega cross I plus y dot omega cross j. Yeah, so we can combine this again. It's a recurring terms, so omega cross x dot I plus y dot, it's a recurring term, so x omega cross I, so I'm going to take the omega out and then cross x dot I plus y dot j. So it becomes like, this one becomes relative acceleration A, x double dot is I plus y double dot j is relative acceleration B relative to A, and this becomes like, so we have plus omega cross R B relative to A. So now we can put everything together. So coming back to here, yeah, look at the whole term AB AA. We have got here three terms. So we're gonna combine everything. So we will have now AB. Yeah. So this is one term that we need to cover, and then this another three terms here, d over dt. So I don't have a space to write it down here, so I'll put everything in there. Yeah. So let's see whether we can put everything there. So it's equivalent to AA, which is here, plus